Hello and welcome. In this video, I'll walk you through the OpenEdge Memory Profiler, a powerful visualization tool designed to help you analyze memory usage in your ABL applications more effectively. Here's what we'll cover today. Use case: why this tool was developed and the problem it addresses. Solution: how the tool works and integrates into your workflow. Key features: a walkthrough of the tool's capabilities. Value proposition: the benefits and impact of using this tool. Demo: a practical demonstration to showcase the tool in action. All right, let's dive into the problem statement and explore why we designed the OpenEdge Memory Profiler in the first place. There are many memory profiler tools available for various programming languages. However, ABL has lacked such a tool until now. With OpenEdge 12.8, the ABL runtime introduced support for instrumenting ABL applications, allowing developers to generate memory profiler recording data files. But the challenge was, ABL developers didn't have a visualization tool to open or interpret these files, making it difficult to analyze memory usage effectively. Our objective was clear: create a tool that visualizes memory profiler recording data, enabling users to self-diagnose memory consumption issues. We've built a visualization tool that parses and presents memory profiler data in an intuitive format. This empowers developers to diagnose potential memory leaks, identify bottlenecks, optimize allocation strategies, and ultimately, it helps improve application performance. So, what does the OpenEdge Memory Profiler offer? Support for .oemp files. These are processed memory profiler recording files used to extract and visualize memory usage data. Memory trend visualization displays memory usage trends over time, helping developers understand how consumption evolves during execution. Tag-based filtering allows filtering of memory graphs using tags like _pre-cleanup, _end-of-request, and more. This helps focus on specific lifecycle stages. Snapshot summary provides detailed summaries of objects in a snapshot, including stack traces for deeper analysis. Snapshot comparison enables comparison between two snapshots from the same recording to identify changes in memory allocation and object retention. Let's talk about the value this tool brings. Boosts productivity. Stats and visualizations make debugging faster and more intuitive. Supports leak diagnosis. Provides the data needed to investigate potential memory leaks. Highlights inefficiencies. Makes it easier to spot and address inefficient memory usage. Simplifies debugging. Clear insights and stack traces reduce time spent on memory-related issues. Now, let's jump into a practical demo to see the OpenEdge Memory Profiler in action. Welcome to the home page of the OpenEdge Memory Profiler tool. This page displays all memory profiler files located in the watch directories. By default, the upload and import directories are configured as watch directories, and any files placed here are automatically detected and listed in the UI. The application is set to auto-import files from the import directory. For example, when a file is added to this directory, the application refreshes periodically and updates the list. You'll see the new file appear as a card showing recording name, start time, application name, file size, total snapshots, recording duration. You can search recordings by name and also use the various sort options that are available here, such as sort the recordings by start time, alphabetically, or by file size. You can view two sample recordings that come preloaded with the tool and represent execution of an ABL program. Sample.leak contains undeleted JSON objects that have resulted in a memory leak. And sample.normal file shows stable memory consumption over time. To analyze a recording, click the Review button. This opens the memory usage page and adds two tabs to the side menu. Snapshot tag _pre-cleanup. Snapshot tag _exit. The page is divided into three sections. Graph section displays memory usage trends. Recording details contains metadata about the recording. The tags table lists snapshots grouped by tag name. Each snapshot has a tag name categorized as system tags, which are automatically generated by AVM. For example, auto, exit, and so on. Then there are user tags, which are created programmatically by developers. Here in this example, after, done, and pre are user tags. To analyze memory impact of specific logic, Developers can take snapshots before and after execution and compare them. Here in the graph section, there are two graphs. Lower graph, which displays the full recording duration, and the upper graph provides the zoomed view based on selection in the bottom chart. As you adjust the lower graph, the upper graph updates accordingly. You can filter graphs by tag. Note that all tags are selected by default. System tags can be removed to focus on user-defined snapshots. Tags can be selected via this drop-down. This helps isolate memory usage during specific lifecycle stages. There are two ways to view snapshot details. From Tags table, click a tag to view snapshots, then select the desired snapshot ID. The Snapshot Summary Details page opens. From Graphs, click a data point and choose View Snapshot. If multiple snapshots exist in the same second, a drop-down appears to help you select the desired one. By default, the graph displays the snapshot with the highest memory usage, helping you focus immediately on the most relevant data. You can also view platform memory from this page. As you know, platform memory includes memory consumption by essential components and processes necessary to run an ABL application. An application memory includes memory consumption by the objects that are created while running an ABL application. Now, let's look at the Summary Overview tab. The Summary Overview tab includes details such as application and platform memory, object count, widget pool count, temp table count, and two plots displaying the top 5 memory-consuming objects and top 5 classes with most instances. In this example, take a look at this class. It has 101 instances. Now compare that with another class that has 50 instances. But what's even more interesting is the memory usage. This particular object is using nearly 1.1 million kilobytes of memory, while another one is using close to 104 kilobytes. And as you go through more objects, you'll see similar variations in memory consumption, which can help you pinpoint what's taking up space and where you might need to optimize. There are 5 different views or tabs. The OOABL class's view displays class name, instance count, total memory. Here, all the OOABL classes are listed and sorted based on the total memory in the descending order. You can expand entries to view objects and click IDs to see call stacks and trace where a particular object has been created in the code. Here, the memory column specifies the sum of the memory used by the selected object and the memory used by the objects that are scoped to it. The base memory specifies the amount of memory used by the object. Similarly, the procedure view show each of these object types in the selected snapshot based on the total memory in the descending order. The procedure view shows name, instance count, total memory, expandable object details, and stack trace access. The ABL types view displays list of ABL objects grouped by the object type. This list does not include the OOABL types and is sorted by the total memory in descending order. Widget pools are categorized as named or unnamed. For widget pools, the scope to column shows the object each widget pool is associated with. The temp table view displays temp tables grouped by their type, showing instance count and total memory. Again, you can expand each row and see ID, name, base and total memory, scope, and instantiation status. An important thing to note here is that memory shown is schema memory, not actual memory based on record count. To begin comparing memory snapshots, you need to select 2 snapshots from the upper graph on the memory usage page. Note that you can only compare snapshots from the same recording. First, choose a snapshot from the graph. Simply click on the desired data point. A dialog box appears. Click on Add to Compare. You'll notice that the selected point is now highlighted, and a small tile appears in the top left corner of the chart. If you change your mind or selected the snapshot by mistake, you can click the cross on the tile to remove it. Let's go ahead and add it back again. Click Add to Compare. Now, we need to select a second snapshot to complete the comparison. I'll choose another point on the chart. As soon as I do, a new button appears. Compare with Snapshot 6 or whichever snapshot was selected first. Clicking this button opens the snapshot comparison page where we can analyze the differences between the two selected points. Now let's look at the snapshot comparison page. Like the summary details page, the snapshot comparison page also contains several views or tabs. The Overview tab shows summary of both the selected snapshots and also a table sorted based on the memory usage difference in descending order. So, what this view helps with is understanding which categories of objects are using more memory in the latest snapshot compared to the older one. For example, in this case, we can clearly see that memory usage has gone up for the OOABL classes. Just to give a broader picture, I've opened another example as well. Here, we notice that ABL types are consuming more memory, followed by OOABL classes and then temp tables. There's also a handy feature called count difference, which shows how the number of objects has changed, whether more were created or deleted. It's a net count, so it gives you the overall difference in object count for each type. For instance, in the widget pool section, there's a net increase of one object, meaning a new widget pool was added. This could either mean that a new widget pool was created since the previous snapshot was taken, or an old widget pool was removed and two new ones were created, resulting in a net increase of one. This change can help you understand how memory usage is evolving. Now, the table is sorted by memory difference, which makes it easier for you to focus on what's causing the biggest increase. In this example, ABL types stand out with a significant memory spike. So, you can drill down into ABL types to investigate what exactly is contributing to that increase. Moving on to the OOABL Classes tab. Here, objects are grouped by their class name. The table shows the class name, memory usage in both snapshots, the memory difference, and the count difference. You can also see how many instances were created or deleted, with plus and minus signs indicating those changes. When you expand a row, you'll get a detailed view showing how much memory each object is using in both snapshots, so you can compare side by side. If an object was newly created in the latest snapshot, it'll be marked as created. If it exists in both snapshots, it's labeled as active. And if it was present earlier but missing in the latest snapshot, it's categorized as deleted. This breakdown makes it super easy to track how individual objects are behaving over time, whether they're new, still around, or have been removed, and how that's impacting overall memory usage. Just like on the Snapshot Details page, you can click on a specific object to view its call stack. If you want to copy the stack, there's a copy icon right there for that. Tabs for procedures, ABL types, widget pools, and temp tables show differences between both the snapshots in terms of memory, base memory, and count. You can expand object details, view, and copy stack traces. You can also customize table columns using the column selector. Stack trace and column customization features are consistent across all tabs in the tool. That concludes our demo of the OpenEdge Memory Profiler. Thank you for watching. For more content, visit docs.progress.com.